Okay, so this is number 8, and this is called the test for independence. And here's the problem. We're going to use the traditional method of hypothesis testing. Here's your 5 steps up here. Here's the problem. The study is conducted as to whether there's a relationship between joggers and the consumption of nutritional supplements. A random sample of 210 subjects is selected. They're classified as shown. At alpha equal 0.05, test the claim that jogging and the consumption of supplements are not related. For example, people that maybe at Runner's World might be interested. They might want to know whether they should be, or people that maybe sell supplements might want to know if they should advertise in Runner's World magazine. Those might be people that would be interested in this statistics, or in this data. Okay, read that again. Test the claim that jogging and consumption of supplements are not related. If they're not related, that's called they're independent of each other. Okay, if they were related, we'd say they're dependent. So in other words, we don't think that being a jogger or non-jogger has any influence on whether you take nutritional supplements or not. Or that's what they're claiming. Why might supplement manufacturers use the results of these studies? Well, again, it might help them know where to advertise, who to target, who to market towards. Okay? Here's the data they give. Jogging status. They have 34 people that jog daily, 52 that jog weekly, 23 that jog as needed. Then non-joggers. Excuse me, I said that wrong. 34. These are 34 joggers that use nutritional supplements daily. This is 18 non-joggers that use nutritional supplements daily. This is 52 joggers that use nutritional supplements weekly, 65 non-joggers that use nutritional supplements weekly, and then 23 joggers that use supplements as needed, 18 non-joggers that use supplements as needed. So these are the numbers. The as needed involves how often they take the supplement. Any questions about the problem? Put the lights on.
I'm bored. That last one. Non-joggers as needed.
Yeah, I think I have a wrong number up there. I'll switch that quick. Thank you for seeing that. I don't know where I came up with 101, but supposed to be, let's make sure, 18, yep.
So 101 is the sum of that row.
Okay, that's probably where I got it then. This should be 18. All right, so these are what we call our observed values. You want to do some type of survey, and you come up with your data. Those are called observed values. Our null is going to be that the consumption of supplements is independent of being a jogger. There's no relationship between whether you take supplements and whether you're a jogger or not. That's the claim, that there is no relationship. The alternative hypothesis would be that the consumption of supplements is dependent on jogging status. In other words, that depending on whether you jogger or not, that may influence how likely you are to be taking supplements. So we're using independent, dependent. You always use, in this test, you always use the word independent in the null and dependent in the alternative. Second thing we're going to do is find the critical values. Now the critical value formula is a little bit different than what you've been doing. If you look on your formula sheet, the degrees of freedom formula is you take the number of rows minus 1 times the number of columns minus 1. So degrees of freedom is you take the number of rows, we'll call that R, minus 1, times the number of columns minus 1. So in this case, you have rows go across, you have 2 rows and 3 columns. So to get the degrees of freedom on this problem, 2 rows minus 1 times 3 columns minus 1. So that comes out to 1 times 2, which would be 2. Degrees of freedom is 2. So then you go to your chi-squared chart, and you go down the left side, degrees of freedom of 2. You go to the top for alpha of 0.05, because that was given in the problem, and you get your critical value. Critical value in this case, you go across from 2 over to 0.05, 5.991. I'm just getting that off of this chart. that means is that we have our chi-square distribution, which is generally skewed right, starts at 0, that critical value's out here, at chi-squared equal 5.991. If we get a test value that's larger than 5.991, then we will reject the null hypothesis. Any questions on that? All right, the next part. We're going to find the test value using this formula, which is the same formula we use on the goodness of fit test. But it's a little bit tougher because you have to figure out the expected values. And to figure out the expected values, we've got a different formula. And again, this is on your formula sheet. To get the expected values, you take your row sum, move this down a little bit, row sum times the column sum divided by the grand total. So row sum means we add up the rows. So if we add up 34 and 52 and 23, that adds up to 109. That's your first row sum. If you add up 18, 65, and 18, that adds up to 101. Add those together, you get a grand total of 210. That's your grand total. You're also going to need the column sums. 34 plus 18 will be 52. 52 plus 65 would be 117. And 23 plus 18 would be 41. And of course, if you added up those three numbers, you'd get 210 also. Any questions about how to find those? Okay. Now we're going to have to find these are my observed values. We have 6 of them. We're going to also have to find 6 expected values. So I'm going to go and find the expected value for row 1, column 1. I'm going to call that E sub 1, comma 1, meaning I'm finding the expected value for that spot. Row 1, column 1. So the way I do that, I take the row sum for this row would be 109 times the column sum, which would be 52. So I do 109 times 52 divided by the grand total, which is 210. That gives me 26.99. So the expected value there is 26.99. The observed value is 34. Do the same thing for row 2, row 1, column 2. Expected value for row 1, column 2, I would take 109 times 117 divided by 210. And that would come out to 60.73. Now I'm going to do expected value for row 1, column 3. So row 1, column 3 is right there. So the sum would be 109 times 41 divided by 210. That comes out to 21.28. Now I'm going to go to the second row. Row 2, column 1. So if I'm in row 2, column 1, I want to take the sum of the second row, which is 101 times 52 divided by 210. Which comes out to 25.01. Expected value for row 2, column 2, the observed value is 65. The expected value, I take the second row sum, which is 101, times the second column, which is 117, divide that answer by 210, 56.27. Expected value for row 2, column 3, I take the sum of row 2, which is 101, sum of column 3, which is 41, multiply them, divide by 210, I get 19.72. Those are the expected values. Any questions about that? All right, now I'm ready to use my chi-squared test value formula, my test statistic formula. So what I do to get chi-squared is I take my observed minus my expected. So my observed here is 34 minus my expected, which is 26.99. And I square that answer and divide by 26.99. So I've used this one and this one. Now I go through, now I do my second value up here. I'm going to go 52 minus 60.73. I'm going to use those two. I'm going to add these together because of the summation form, symbol here, sigma. So I do 52 minus 60.73 squared divided by 60.73. I'm going to do that for every single entry. So now I'm going to go 23 minus 21.28 squared over 21.28. Plus, I'm going to bring this down here where I can, so I don't run out of room. Plus, then I'm going to go down to here. 18 minus 25.01 squared divided by 25.01. You don't necessarily have to write this all out on your paper. You could just type it in your calculator. That would be fine with me. Now we're to the fifth value, 65 minus 56.27 squared divided by 56.27. And finally, 18 minus 19.72 squared divided by 19.72. Type that whole thing in your calculator. That's going to give you a test value of, anybody come up with anything? My notes say 6.67. That should be the test value you would get if you type that all in your calculator. Now, once you get that number, you compare that with your critical value. 6.67 would fall to the right of 5.991, meaning that we would want to reject the null. It's in the rejection region. So for step D, we would say we're going to reject the null. Which means for step E, if we reject the null, that means we think the null is not true, and the claim is the null, so we'd also be rejecting the claim. So we'd say there is enough evidence to reject the claim. We reject the claim that that consumption of supplements and jogging status are dependent. Or independent, excuse me, or independent, thank you. So, let's think, what does that really mean? Is there some type of relationship between whether you're a jogger or not and whether you take supplements? What do you think? We're rejecting that they're independent. Independent means there would not be a relationship.
Oh, yeah.
We're rejecting that, so yeah, so someone's coming along and saying, hey, there's no relationship between being a jogger and whether you take supplements or not. We just rejected that, so we think there probably is a relationship somehow.